Hey, welcome to part 9 of the Dream Home build. This video will be all about our geothermal installation. I had literally had hours of footage and there's just so much to pack into one video, so I'm going to try to refrain from talking too much about the geothermal concept itself and try to just strictly focus on the installation. To make geothermal affordable, we had hired a really good company to install all of the ductwork and the units, but we did all of the drilling, the lines separately. In total, I had about 3 or maybe 4 different companies and myself installing this system. Apart from saving money, I also wanted to use a method that no one really knew about a lot in our area. So by providing many of the materials and installing them ourselves, we were able to get the results that we wanted. The geothermal ground loop was going to be a vertical loop that consisted of 4 individual wells, each at 300 feet deep. Here's the rig that was doing most of the drilling, using a 4-inch diameter bit. What was super cool to me was the various layers underneath the ground. I had no idea that there was so much going on underneath the ground, like all the layers of sand, the different kind of rocks, and depending on what kind of material it is, things can go either smoothly or very difficult. I spaced each well out by about 20 feet in a straight line. I had to be within a certain minimal distance from our septic system, and I also wanted to place the wells in an area that would not get covered by like a permanent structure in the future, perhaps like a shop or something else. If you've seen my previous videos, you'll know that we used a lot of Rehau products in the house build. Rehau also specializes in geothermal ground source supplies. I believe their line of products for geothermal systems is called Raugeo. Specifically, their double U-bend lines. These are PEX lines instead of HDPE, which HDPE is what's used mostly here and locally by our installers. Traditionally, you send tubing down your vertical well that goes all the way down, and then it sort of U-bends back up and returns back to the system. This allows the ground source water to go through all the way and get really good thermal exchange with the ground around it. However, you can take it one step further with the Raugeo double U-bend pipes, which consist of an additional line going in and out. Here you can see me uncoiling the double U-bend lines and what the end of it looks like. At 132 feet into the first well, we hit water. Now the state requires that when drillers hit water, they have to record the volume of water output, which turned out to be something like 3 or 4 gallons a minute, which isn't actually considered very high. What's crazy is that after this first well was drilled, none of the remaining 3 wells had hit any water at all. To make inserting the double U-bend pipe a little bit easier, I attached a piece of rebar and taped the first 8 or so feet of it together with the pipe so that it would be straight. As you can see, the rest of it is just 4 loose PEX lines. Now here's where things got really stressful. No matter how we tried to insert the tubing, it would not go down past about 15 feet or so. It would just stop. We spent probably an hour or more inserting, taking it out, re-drilling, cleaning out the hole, inserting again. The sun was literally setting and we still could not get the tubing to go all the way in. It turned out that there was a limestone ledge beneath a sandy layer, and the sand had basically given way and made it to where we were aiming for a small 4-inch wide hole in the limestone rock about 15 feet under the ground, and each time we would just hit the ledge of it instead of going right through. The next day, the guys came back out with a larger rig and they drilled about 25 feet deep of a 6-inch wide well instead of 4. That way they were able to insert a liner or like a sleeve, which is basically just a wide PVC pipe that would help guide the tubing down for the first 10 or 20 feet or so. And guess what? It worked on the first try. And what's crazy is that the other 3 wells worked seamlessly, no issues at all. To help guide the tubing down, we also filled some of it with water to weigh it down. This helps the tubing fall into the well a lot easier since it's heavier. The material they're pumping in is called bentonite grout. It fills in the voids in the well, basically the space around the tubing and the dirt around it, which helps with the thermal conductivity. When they mix it up with water, it looks kind of like a thin, runny sludge, and they pump it in, but eventually it thickens up and seals up the well, which also prevents surrounding groundwater from potential contamination. So you're kind of like creating a little pond for it?
Yeah, that way 'cause it'll settle. That way it's not boring, just staying topped on.
Oh, you can hear it like gurgling in there.
Oh yeah.
How long does it take for that thing to fill up?
Oh, depends.
15 minutes?
20 minutes.
Wow.
Depends on how much you got to pump and how deep the hole is.
Right. And so if these loops weren't filled with water, they would just want to float up, wouldn't they?
Yeah.
Because they're buoyant or whatever.
Right.
The geothermal units we got were the WaterFurnace 5 series units. Both are 5-ton systems. The water-to-air unit would provide air conditioning and forced air heating in the house. And the water-to-water unit would eventually provide hot water for the radiant heating system when it would be ready to go. Taco Bell.
Yeah, what it looks like.
My excavation guy later trenched all of the 4 wells into one connecting point that then led into the house. Okay, so we have 2 wells coming from this direction. Each well has 4 lines because it's a double deep end. And so as we're coming out of the wells, we're backfilling a little bit to keep everything organized. We're also trying to organize the lines this way so they're more flat and not overlapping. This way we maximize the heat exchange potential of the lines. It's almost like weeding. This is another unique thing about the Raugeo system. It uses a stainless steel manifold to connect all of the circuits together that then go through the main supply and return lines to the house. So here's what we did. We have level of grass, which is the original elevation, and then we have everything that's trenched underneath, and it's about 6 feet tall. It's about my height. And what I've done is I've laid a 2x6 across to be able to get an idea of the grade, and we were told that we want to go about 12 inches above grade to help level out the actual situation above the vault box. So below, now this is a 3-foot vault, so this total length right here, height, is 3 feet, and everything's going to go in the ground underneath with some gravel on top. And there's no real issue with burying these fittings. I mean, they're actually designed to withstand that. So I'm hooking up all of my connections here. This is the 1 1/4 inch Rehau stainless manifold. So yeah, here we go. To make sure I didn't have any leaks, I had to do an air pressure test. 65 psi or so. By the way, the trench coming in there from the far left is actually the main water line and the underground power feeding the house. These all had to get buried at different depths, including the main geothermal lines. So, since this manifold actually allows us to balance the flow of each individual circuit, or aka well, we preferably wanted to have constant access to this manifold. This is why I got the vault for this system. And the best way to bury the lines without causing too much settling is to use washed gravel. At least that was what my excavation guy recommended. Alright, so I did warn you that this video is going to be super long and extensive because this next part is me running 1.5 inch PEX lines out from the foundation and over to the main flow center for the geothermal units. To attach my lines to the foundation wall, I elected to use Unistrut, which ended up looking pretty good in my opinion. Of course, that required a ton of drilling into the concrete and using a lot of Tapcon screws. Also, you can see the Geolink flow station pumps right there on the left. Now, if you're wondering what this is a Rehau Everlock tool. However, it's a little unique because it's for fittings that are 1 1/4 and higher. I think it goes all the way up to 2 inches. And compared to the other one, this thing is a beast. It is really heavy. This is without all the fittings on, or the claws. So we are dealing with 1.5 inch pipe. So, not that one, but here's the 1.5 inch expander. First, we gotta put this thing on. That'll slide onto here, like this. And then we have our sleeve and fitting claws, 1.5 inch. I don't think it really matters which way you put them. There's the fitting side, and here's the sleeve side, all 1.5 inch expansion PEX for Rehau Everlock fittings. Right now what I gotta do is I gotta attach a 90-degree elbow to both of those, so we can go up, and then we can go left, and then we can take another left, and go all the way over here, and when we get here, we can go back down. If you're wondering what those fittings look like, we have 2 components to the fittings. We have the sleeves, which a 1.5 inch sleeve is pretty big. Here it is. This gets forced over the expanded PEX that's already over the fitting, in this case an elbow. And this right here would be the actual elbow itself. These are so big that they come in their own packaging, one at a time. And again, the key thing to remember about expansion style PEX, at least in this case, is this fitting is large and requires you to expand that PEX to go over it. And the good thing about that is the flow isn't as restricted inside. So basically the inner diameter of your fluid flowing through does not get reduced. Okay, so right about this time, I about gave myself a heart attack because I cut the PEX tubing so short that I didn't think I was going to be able to get the tool behind the PEX sleeve, which, by the way, these 1.5 inch PEX lines are absolutely impossible to move at this point because they're buried in the ground outside of these foundation walls. But after some creativity, I was able to attach the elbows, and also I got so hot from panic that I had to remove my coat. The rest of the PEX connections were really easy. These 1.5 inch PEX sticks are always easier to work with than working with PEX tubing that comes off of a coil. What I'm doing here is I'm adding a T-fitting onto both lines that will allow us to bleed air out of the system. Since these 2 points are the highest in elevation for the entire geothermal system, I was able to use little 3/4 inch ball valves as my manual air bleeders. So I'm wiring up the 5 series unit, and there was basically on just the air handler unit itself, what I mean is the water to air unit, there's basically 3 circuits you're going to run. This circuit down here runs the compressor and powers, I believe, pretty much everything else besides the auxiliary heat. And so you have a minimum circuit rating of 46 point something amps. So basically you got to jump up to a 50 amp circuit, which requires at that point 6 gauge wire, which is what I have right here. And I originally was going to use 6/3 wire because I thought, you know, this unit would have a neutral lug somewhere, but it didn't. It just had your typical, you know, hot, and a ground back there. Now there was 2 ground lugs, so I could theoretically, if I had an extra neutral, like an extra conductor, I could have ran it there. But since I could get away with the 6/2 wire, it was going to be 1, cheaper, and 2, easier to run and manipulate through all the fittings and whatnot. So here I am. I've got L1 and L2. Those are my hots. I've got the black in there, and I'm about to do the white. And I found that leaving about 3/8 of an inch of bare wire here is the best. You don't want any more than that, otherwise you end up seeing too much copper, and that always kind of freaks me out because, you know, I don't know. Nothing should touch that, but, you know, don't expose too much. And then, of course, my ground is right there, right where it says ground, where the camera won't focus. And of course, since I'm using 6/2 cable, I've got a red and a white, and the white is typically a neutral. So in my case, on my breaker panel, it's very important that I put like red electrical tape or something to notify the viewer or whoever's going to access that panel that that white wire is hot. It'll be a double breaker, and on this white wire I'm going to put red electrical tape and maybe write something on it. That way the person knows that they're both hot wires and not just, you know, a neutral plugged into a very funny location. Okay, now here's an example where you have 10/3 wire, 10 gauge, 3 conductors, and a ground. And in this case, you only need a conductor, and a ground. So the neutral, what we do in this case, best thing to do is put a nut on it, twist it back, and do the same thing on the breaker panel. That way, if somebody ever comes over there and sees this, they'll know that this neutral is capped off, therefore there's nothing in it but the The red and the black have power, 120 volt each. So I'll go ahead and connect them now. This is a 30 amp and a 60 amp. So 30 amp, you're allowed to use 10 gauge wire, which is what I'm doing right now. Now a little note on the water to water unit. That unit is strictly going to be used for radiant heating. Since this video isn't necessarily about radiant heating, I'm not going to spend too much time on this section. However, I wanted to show you my experience running electrical to that water to water unit, which by the way is a 5-ton series, or a 5-ton unit, 5 series unit that was capable of supplying about 120 degree Fahrenheit water output. And at the time of me editing this video, like while I'm talking right now to the microphone, this water to water unit is actually running already and supplying hot water for our radiant heating system, which is working very comfortably. Also, when I say water to water unit, what that means basically is a geothermal heat pump unit that instead of heating or cooling air, it's exchanging with water. So basically you're heating or cooling water. Now, if you're wondering why I'm taking the sheeting off, it's because the conduit here, watertight conduit, acts as an insulator. So you technically don't need the extra sheeting. But the biggest reason is I'd leave it in there otherwise, but it's very difficult to push 6'2", let alone like 6'3" cable through this 3/4 inch watertight conduit. And so this is just going to make it a lot easier. Yeah, if I had the sheeting on, it would be, I'd have to put like soap in there or something to make it go, which I don't know if that's okay or not, but that'd be the first thing that comes to mind. Something to lubricate it. Even now, it's like, you can feel it starting to slow down. It's increasing the friction as you get more and more of it in. Okay. All right, now I've got my 2 hots and my ground. I'm ready to connect away. And that's the unit all wired up. Got my cable coming in here. My hot white in this case is L1 and L2 is my hot black. My ground is kind of running behind right there, behind everything, and going into the ground lug back there. Now I'm gonna put a little piece of red tape on that white neutral wire, indicating that it is a hot wire. I'll do the same thing on the breaker panel. That's probably the more important spot to do it at, but if somebody clueless gets in here, they might for some odd reason think that's a neutral wire and not something under power. 30 seconds.
And then I just hold her for 30 seconds.
Do you feel it like slipping in, or?
Yeah, you can.
Now in this next part, the tech came out to do some fusion connections, which is what's used for HDPE pipe connections. Remember I told you that HDPE was typically what's used around our area? Well, think of it as melting pipes together instead of using mechanical fittings like PEX tubing does. How do you know when it's been 30 seconds?
Counting in my head.
I thought you had some kind of special approach, like, hey, I can only hold my breath for 30 seconds, so.
It just melts together.
I guess during a pressure test or anything like that, you'll see if there's any kind of leaks,
sure.
right?
Yep.
Is it pretty common to get a leak, or is it very rare?
Never had one. Actually.
Really? Okay, never had one.
Now that we say that.
Right, well, you know, it's inside the house.
Jink ourselves.
And it has its own little bag.
Yep.
Oh, that's because it's probably really hot. So it's
Yeah, 500 and some degrees in there.
Okay. We'll pay you royalties. Are you just watching for bubbles?
How far it goes up and down when we release it. So if it goes way down, you know there's still a bunch of bubbles in it. If it just barely moves up and down, you're pretty close to where it should be.
Meaning it's compressing air if you shut off the return.
Forcing it and then force it out.
Ah, okay. Can you visually see bubbles coming out, or I guess you
Sort of. If there was a bunch, yeah, it would be bubbling like crazy.
Mm-hmm.
But since we've already got it out, there's not really anything.
It's it just looks like Kool-Aid.
Yeah, glycol. Yep. Slimy.
It's a little slimy.
Yeah.
After filling up the geothermal lines and bleeding all the air, this video is the unit running for the very first time. It's like its maiden voyage, and it's heating up the house. People often ask us if geothermal or even radiant heating is worth it or not, and the answer is always the same. It was worth it for us because we did a lot of the work ourselves, and if you're genuinely interested in geothermal systems, then I feel like you should also be genuinely interested in doing, or at least possibly doing some of the work yourself, because honestly, you'll find it very enjoyable, and you're going to learn a lot of cool things along the way.